So today we'll talk about heart rate and rhythm based on the EKG, really. We're going to learn the EKG intro today and what the rate is and how to find it. Okay, so just a little work we would have done in the lab because we get right to it. We get our hands on it and we would put the electrodes on. Now, this particular setup here is called a modified limb lead or limb leads, or let's say even better, limb electrode placement. Because here's the thing. On a standard EKG, 12 lead EKG, you're using 10 electrodes. Just remember that for next week. So there's 12 leads, which means there's 6 limb leads and 6 chest leads. But for today, we would have just done a modified limb placement. So we're just doing limb leads. And the limb leads have 4 electrodes. There's 6 chest electrodes, but we're just doing limb, so there's 4. And here's where they go, like the right arm, left leg, right leg, left leg. So now this is not standard, this is modified. So this is a good placement to use when you're doing your exercise stress tests. This is good to use on somebody who has a broken limb, of course, or you can't get to the limb, or there's an issue with the limb. So these are put on the torso. Modified limb leads are put on the torso, not the limbs themselves. And later on, I'll show you where the placement goes. Now, these electrodes and leads actually have a color coding, and this is standard, so you have to memorize this. So the right arm electrode is white, and the right arm lead is white. The left arm is black electrode, and the right leg is green, and the left leg is red. Remember, modified, we're not putting them on the limb, we're putting them on the torso. So I'll show you later. This is like right midclavicular line. They're all midclavicular line, but there's 2 on the chest and 2 down and just above the groin area. And that's it, that's the 4 limbs. So memorize the colors. The right arm is white, left arm is black. The right leg is green. And remember, green for the right leg is a ground, which means it's not actively recording anything, but it's used as a ground to stabilize the current. And left leg is a red one. So just those you have to memorize. And it's the same thing when we do standard electrode placement, which is on the limbs themselves, like on the wrists for the left arm and right arm, and on the ankles for the left leg and right leg. Some of you might have done this and remember that. So memorize those. Now, I like this. Well, we can just go through the waves first. Now, very important when you read an EKG, and this is just one cardiac cycle here, you always read it from left to right. So you start, sometimes there's a baseline that you could see on the edge. And then you see the first wave is a P wave. And that represents your atrial depolarization, the atrium. And remember, there's the sinoatrial node, SA node, is in the atria, in the right superior lateral wall of the right atrium. So the SA node is the main electrical pacemaker, the fastest pacemaker. So if you see a nice defined P wave, hopefully you're going to have sinus rhythm, which comes from the sinoatrial node. Then you're going to see a delay between the P wave and right here, the R. Well, you'll see a better picture next where you define it, but it's called the PR interval. Now, an interval has a deflection in it. It has a wave in it. When you see the word segment, it doesn't have a wave. So the PR interval timing is very important. I'll show you that on the next page. So the P is atrial depolarization, hopefully from the SA node. And then the next big complex is QRS, and that's ventricular depolarization. So there's a slight negative Q wave, and that doesn't always have to be present, even in a normal EKG beat. The R wave is always the most positive. And then S is a negative as well. So the whole complex is ventricular depolarization. Now, also what's hidden in this complex is atrial depolarization as well. Can't see it. You can't see it because it's hidden within this big QRS complex. And then you have a T wave, which is ventricular repolarization. Now, this is an old English book, so you could put a Z there, and that's probably what the test will say, Z, instead of an S, right? So that's ventricular repolarization. And then the U, which you won't see. We really won't talk about the U. The U is like usually an after conduction of Purkinje cells or something like that. So the main thing here, I don't know where you're in lecture, but you should know what depolarization means in a muscle cell. This is cardiac muscle cell, which have their own pacemaking potentials, hopefully starting with the SA node. So what is depolarization? What does that mean? And it's always about the cell becoming positive, the inside of the cell. That's really what's showing on the EKG, the positive part of the depolarization. So what is depolarization? Kevin, Michaela, I have a feeling you're going to answer most of these. Michaela?
Is it like that electrical part?
Yeah, it's definitely electrical. Definitely electrical. Very good. Definitely electrical. So what ion is coming into the cell to make it more positive? Anybody, just say that. Even if it's wrong, it's okay.
Sodium?
Yeah, sodium rushes into the cell, and that makes it positive. So now, once it depolarizes, it can contract, and contraction is systole. And then once it contracts, it has to repolarize. So repolarization is sodium channels are now closed, and the potassium leaves the cell. And that goes back to a resting membrane electrical potential. Very good. So depolarization is influx of sodium, which leads to what's called an action potential. Once there's an action potential of that muscle membrane, it can contract, and they all contract to form systole. Let's face it, especially ventricular systole. But there's two parts of the heart, like the atria goes through systole too. So there's atrial systole, and then there's ventricular systole. So atrial depolarization, P wave, then you have a delay in the PR interval, and then you have ventricular depolarization, action potential, then you get ventricular systole. That all kind of starts again. Did I lose
Are you
this group?
supposed to be sharing the slide or no?
Not right now, no, I'm looking
Okay.
at my face, but this is really getting messy with a slow computer. Okay, so you have to know what that means. And on the EKG, it's going to show the more positive the depolarization, the more action potential is, the bigger the wave. So you notice this, I mentioned like there's a positive and a negative part of some waves, like a QRS really, especially. The R wave is always the most prominent. Now, this one I like a little bit better. You guys can see this, right?
Yes.
Yeah, I just want to make sure everything's moving fast, so I don't go ahead of you. So the thing is, now this is a typical EKG that you see in a textbook. Let me see, where's my pen? So there's 12 leads, which are vectors and directions of the heart, looking at different parts of the heart in 12 different views. And really that's what it is. But this is something that's very important that you should always remember. When you look at an EKG strip like the one below, which is just one cardiac cycle, you're looking at a limb lead called lead 2, written in Roman numerals like this. If this was, and you could also look in a chest lead that shows an EKG strip like this would be lead V5. But most likely we're looking at lead 2. That's probably the best one to look at. And what I mean by that is you're looking at a part of the heart where most depolarizations are happening, where there should be a nice tall upright P wave, QRS complex, tall R wave really, and P and T. But mostly the R wave is what we're looking at in lead 2, because that's showing a good ventricular depolarization. And what part of the heart is the thickest myocardium? Like think like left side, right side, front, back, lateral, medial.
The left, right?
Yeah, the left lateral wall, yeah, of the left ventricle is the thickest myocardium. So in lead 2, the view you're looking at in that limb lead is the left lateral wall of the left ventricle. So it should be nice upright R wave like you see in this diagram. Now, you see there's boxes that later on, I'll show you what the little boxes represent. This is one little box, and this is a big box, like all of this. There's 5 little boxes across and up and down in a big box. So in an EKG, you're looking at amplitude on the left axis or the y-axis in millivolts. On the bottom, you're looking at time in seconds. Sorry, I can't write there, but it's seconds. So time is on the x-axis on the bottom. So going from left to right, this is going to be the timing. Going from top to bottom is the amplitude of the waves. And that's really all you count. But for heart rate, of course, we're going to be counting the time on the x-axis from left to right. So again, always read an EKG from this side, left side to right side. Make sure you have a good P wave, a sexy P wave too. You know, it's got a nice curve to it. It's not too pointy. It's not upside down. It's not notched. Then I think the next thing you really should look at is the PR interval. And look how it's measured. You can see it right here. This is a very good example of what you need to do in your exercises. The PR interval should be, and just to give this to you now, should be between 0.12 and 0.2 seconds. That's the normal PR interval in time, right? And I'll show you what these little boxes represent as far as time. And if you notice, the segment has no hills, and interval has hills or deflections. So the segment is a nice delay between atrial depolarization and ventricular depolarization. And then we have the QRS with a nice tall positive R wave. And the Q is a little bit negative because of the direction of depolarization. And then the R wave is very positive, and then you have a negative S. You don't always need to see the Q wave on an EKG, or S really. The R wave is the most important, especially in lead 2 or V5, depending on what lead we're looking at. When we get to 12 lead EKG, that's very complicated. Now, I think other things you could measure the QT interval and look where they're delineated. That's kind of where it gets confusing, but make sure you know. ST segments and then the ST interval. So they're all timing from left to right. And here's the T wave, which is ventricular repolarization. So it kind of tells you a little box in time on the x-axis is going to be 0.04 seconds. One big box is 0.2 seconds in time. Now going up and down, one little box is 0.1 millivolt. So each little box is 0.1 millivolt. So 5 of them would be 0.5. And if you had 2 big boxes, it would be 1 millivolt. Like right here, if you were measuring this, like how these 2 boxes up and down in millivolts, that would be 1 millivolt because each box is 0.5 millivolts. Each little box is 0.1 millivolts. I don't know if it tells you that here. No, it doesn't. So each little box is 1 millimeter. So when we do the EKGs, you have to set the calibration to make sure it's on the right frequency. So all these numbers make sense. So the next page is a little easier to understand. So this is typically what the EKG paper looks like. And notice there's a big box that contains the 25 little boxes. And you can see a little box there. So a little box is 1 millimeter. And in amplitude, it's 0.1 millivolt. In time, it's 0.04 seconds. So a big box would be 0.5 millivolts on the y-axis, going up and down amplitude, and it will be 0.2 seconds. Understand? That's really important. You probably learned this already, but it's just good to practice. And
So just to
go ahead.
Just to go back for a second. So the bigger box is 0.2 seconds, and then the smaller ones are 0.04.
You got it. Perfect. Yeah.
Okay.
Yeah. So, but the hard part is like, because this is easy because we're looking at one strip, but sometimes like the strips are like magnified or they look really small and you can't make this out. This is very easy. Like I could see where the big lines are. They're like a little darker. You see that? This one's a little lighter, but that happens. And then you can see what a big box is. And you know, like you said, 0.02 second. I'm sorry, 0.2 seconds across and 0.5 millivolts up and down.
So the whole thing would be a second, like the whole upper.
You mean all this?
Yeah,
if
like
you add all these up. Yeah. But you don't have to think that. You don't have, that's a good point, but you don't have to think that way. Think just really what you're going to wind up doing is looking at the distance between the R waves. Like if there's an R wave here and there, and you have to count these boxes in between. That's what it's going to come down to. And that's the tedious part, that what you'll see. It's kind of easy, but it's tedious. But of course, you have to memorize this. You have to know that each little box, tiny box, is 0.04 seconds, and the big boxes are 0.2. Make sense? And there's 5 in each big box. That's important too, because you got to count the little boxes, which I'll show you. So you can do heart rate by calculating and multiplying the little boxes, the number of little boxes, which is called the RR interval. So there's 3 ways to do it. One is the simplest, but they're definitely not even close to being accurate, but it's close enough. In order to get a 6-second method heart rate, you need what's called a 6-second strip. So you have to know it's a 6-second strip. I have to tell you, I won't make you count the 30 boxes, the big boxes. You just have, I will tell you, this is a 6-second strip. Tell me what the average heart rate is, or the approximate heart rate, I should say. Then we do the RR interval, which is the most accurate of the way of counting it. So now the RR is counting the little boxes between the R waves, and then multiplying that by 0.04 and dividing into 60, which you'll see. Now, the third method we're going to use is a memorization of the RR interval method. So you'll see, you'll memorize 300 is one big box from the start, then 150, the next big box line, and then 100, and then 75, and then 60, and then 50, and I believe the next is like 47, and so forth. But I like you to learn down to 50. Memorize 300, 150, 100, 75, 60, and 50. And that'll be really helpful to get a quick heart rate. And this is a good method to use. It's not exact, but it's pretty close. So the 6-second strip you could use for any irregular rhythms. And I'll tell you what irregular means. But for the irregular method, something's really irregularly irregular, like it's all over the place, you can only use the 6-second strip. So remember this, you can't use the RR, the 300, 150, 100 for irregularly irregular rhythms. Very important, but simple once you learn it. So this is what I would tell you. Now let's do this together. Again, I don't know if you people are awake, but it's really important that you stay with me here. There's way too many people in this class. There's like 24, just really hard to really stay alert, especially on Zoom. So do your best. So this is a 6-second strip. I'm telling you, this is a 6-second strip. So first thing you need to do, again, is look at from left to right at each beat. There's a P wave there, but it's not sexy. It's ugly, actually. There's a normal QRS. It has the right width, which you'll find out later. And this happens in a regular rhythm. It's happening with the same amount of boxes in between the R waves. Remember, this is an R wave. How many R waves do you see here? How many QRS complexes? How many cardiac cycles do you see on the 6-second strip?
5.
Yeah, there's 5. So all you have to do is multiply the 5 cardiac cycles times 10, and you get 50 beats per minute. Now, that's not going to be exact. In fact, it's about 15 or so off. But at least you know this is a very slow heart rate. And you always have to assume this is at rest. You understand? So the thing is, to know it's regular, you have to know when to expect the next R wave or next QRS. And you could like take a piece of paper and put a little mark and then move the paper from beat to beat, make sure they line up. If they don't line up, you may have a irregular rhythm. And you can still use a 6-second strip for that, but you can't use the RR if it's irregularly irregular. So you learn here, you can see what's going on. But this is very simple, but you have to be told that this is a 6-second strip to be able to get this approximate, it's not that close, but it's close enough, heart rate. Now here's the most reliable and the most accurate. Now what we're gonna do here is count the little boxes between R waves. Like here's one R wave and here's another. And also you have to make sure this is regular. Does the R waves come at the same distance, the same amount of boxes if you like? But you could expect when the next one's gonna come. And you use your calipers on your paper, you draw the line and you move it over, but always do it left to right, of course, left to right. Make sure those lines line up and then you have yourself a regular rhythm for what EKG you're looking at. So you count up all the little boxes between the R waves. Like this one, this is kind of subjective, right? You have to look, I would say there's 4 boxes here, and then 5, 10, 15, 20, 25 plus 4. Little boxes between those R waves, right? Let me do it again. 5, 10, 15, 20, 25, 29 boxes. So what you would do is to get the heart rate, you do the 29, which is the RR interval, and it's regular, so it's between all of them, and you multiply that by 0.04, and then you divide that into 60. So do that. Somebody just take out a calculator or your phone and multiply 29 times 0.04, and what do you get? And divide that into 60. So you'll have a calculator. You need a calculator to do these exercises and on the test too.
51.72.
So that's the heart rate here?
Yeah.
Okay, 51.72. You could round that up to 52, it's okay. And don't forget to put the beats per minute. So you could also do it this way, it's a little faster because 0.04 divided into 60 is 1500. So divide 1500 by the RR interval, which is 29. And what do you get?
It's the same thing.
Exactly, yeah. So that's a quick way to do it. And that's the most accurate, actually. That's the most accurate. Now, the fastest way to get to this, it's still approximate though, is you could memorize it. But let's do another one. Let's do this one here. I think this one's the same. Yeah, it's the same thing we did. What about this one? How many little boxes, this is magnified, but how many little boxes are between these 2 R waves? So these are 5 plus 1. So what is it? How many? 6, right? You agree?
Yeah.
Right? So you don't even have to multiply if you just put it into 1500. So what does that come out to be? This is fast now. Look how close the R wave. So this is going to be a fast rhythm. What do we get? 1500 divided by 6.
250.
250? Yeah. So 250 beats per minute, which is very fast, especially if it's at rest. If you got problems, if it's at rest. It's so fast that you can't even see if there's a P wave here. It looks like the P is buried in the T wave. Everybody see that? Because the next one is probably going to be right here. And again, P wave is buried in the T wave. So this is the RR interval method, which you can't do with irregular rhythms. Now, this is a way to memorize. You're memorizing the lines, and you're memorizing the RR intervals. But always remember, like here's 2 beats, right? There's one here and one here is the next beat. And here's the R wave. So you don't count the R wave. That's the starting point. So the R wave is the starting point. And it's right on the the thick line, so it's easy. So always try to find the R wave that is closest to the thick line that starts a big box, like one of these, right? Like sometimes you're not going to find it. Like I'll try to draw this for you. Like if there's a beat where one beat is here, and the next beat is here, and the next beat is here, so forth. You want to start with the one that has the most approximation, the one that's closest to the big line. So in this case, you start here, you don't count that one, then you have to memorize now, 300. So say it together, 300, 150, 100, 75, 60, and 50. Now, where did the next R wave fall between? What two numbers? I can't see the chat, so you have to speak out.
75 and 60.
Yeah, it's between 60 and 75. And it might be, like if you look at this, it might be closer to the 60. Does that make sense? So the answer is basically between 60 and 75. But then you could check it by doing the RR method, by measuring 5, 10, 15, 20, 23 divided into 1500. And what would you get there? Like do 1500 divided by 23. And we're going back to the RR interval method now. So it's between 60 and 75. What number did you get? If you divide 23 into, what'd you get?
65.
Yeah, 65. That makes sense, right? It was closer to 60. So that's pretty close. Closer than a 6-second strip anyway, right? So 65 beats per minute. Very good. So you can do both. And you check, and that's what you'll do on the test and the practice. You'll do, sometimes you'll be asked for a 6-second strip. Then you'll do the RR interval method. And don't forget the 0.04. And then you'll do the memorization, the 300, 150, 100, 75, 60, 50. And the only way you're going to learn is by saying it over and over, which I didn't hear anybody say it, but that's okay because I know we're on Zoom and we're sleeping here. Kind of. So now we're looking at a strip. We got multiple beats. Like how many cycles do you see here? In this EKG right here, this one.
10.
Yeah, I think you're right. Yeah, I think it's 10. Yeah. So that's cool. We have 10. And then what you can do is make sure they're regular. Make sure they're coming at the same pace. Now let's do the heart rate. So here's your starting point. Now this is a good one. It's not always going to happen like this. I'll tell you right away. It's almost never going to happen this way. But the first R wave is right on a big line. So that's easy. We could start right at the first beat. We could have started, what's another good one? None. Actually, that's the best one. There's nothing as close. Oh, no, the second one is good too. The second one is good too. So we could have started at the second and third beat, but let's start at the first one like they have it done. So now we count each big box. We'll do it together. Here's the starting point. You don't count that. 300, 150, 100, 75. So this heart rate is between 75 and 100 based on the 300, 150, 100 method. And you could test that by doing the RR intervals, 5, 10, 15 boxes. So 15 into 1500 is what? Should be 100, right? What is it? 100, right? Yeah, is somebody there?
Yeah.
So again, you have to, it's not me taking the test, it's you. So if you don't understand it, please let me know. Please speak out. And there's a lot of people in this class and I don't know if anybody's going to participate. So this is 100 beats per minute. So it's got a borderline. If this is at rest, it's borderline tachycardia, but it's not. You could say that's normal. Now, again, you know it's regular because the beats are coming where they're supposed to. There's no change in between these beats. And again, you look at this, you'll see it's almost like the P wave is on top of the T, which is exactly what's happening here. The P wave is kind of sitting on top of the T. So it's like a borderline tachycardia, but it's not. I don't think we can call this tachycardia. So if the rhythm is starting with a P wave and a P wave is normal and the PR interval is normal, you can call that normal sinus rhythm. So normal sinus rhythm is a nice sexy P wave with a normal PR interval followed by a normal QRS, and the heart rate is between 60 and 100. Then you can call it normal sinus rhythm. And of course, it has to be regular because there is one arrhythmia in sinus rhythm. That's called sinus arrhythmia, which you'll see at the end of the lab. How are we doing so far with those three methods?
Good.
Yeah, it's pretty straightforward, just tedious when you got to do it in the book. Now, this is just a cheat sheet that I think is in Dubin, in your Dubin book, and it kind of gives you what the heart rate would be on those in between. So you don't just have to say, well, it's closer to 150. You could actually look and see that R wave is here. Like here's one R wave, and the other R wave is here. And you can see that it's actually 167. You don't have to say between 150 and 300 because that's way wide of a range. But you can see that it's closer to 150 in this memorization. So memorize. So this is the starting point. You don't count that. And there's 300, 150, 100, 75, and 60. Okay. So let's do this one. And please stay with me here, please. Please, please, please. So let's do, now you don't count this one. So what's the first number here?
300.
You got it. So this is what, 300 beats per minute. Again, we're lucky because the first R wave is right on the line, as the rest of these two down the bottom too. So this one, again, here's the starting point. So what's this number?
300.
300, and then 150, and this would be 100. But it's between 100 and 50. It's actually right on 150, I would agree. So this one could be 150 beats per minute. And you could double check this by doing the RR method. You divide the 10 into 1500 and you get 150. It's not always that clean, of course. These are good examples. Now this one, again, you start with this one and you count 300, 150, 100, and then what? What's the next number?
75.
You got it. Excellent. So this one is actually 75 too. I think it's right on the line. And I'm not going to split hairs on one or two boxes. So when you do your calculations, do what you see it, the way you see it, as close as you can. And then again, you can do the RR method, 5, 10, 15, 20, and then divide it in, and there you go. So that's the RR method, or I'm sorry, the 300, 150, 100 method is just a memorization of the RR method, but not as accurate. Same thing here. I think we might have seen this. Let me just convert this video. Just give me 1 second. Okay. So we have the bottom EKG. Oh, let's do the top one. I think we've seen this already, but let's do the top one. Here's the starting point. So it's 300. And I don't know if you can see, yeah, this one right here is the 150. So it's just below the 300, closer to 300. And then again, you divide one, you have 6 boxes. We've seen this one before, into 1500. Or you multiply 6 times 0.04 and divide that into 60. So go back to that slide and look at the equation. And that's what you'll get. So 6, whatever 6 into 1500 is the heart rate here. Anybody want to do that one? Or we did it already? I forgot what the answer was. It's pretty fast though. 280 around there, I would imagine. Anybody do it? Let me know. Okay, well, so let's look at the bottom one. And again, I think the first thing that at this point you should be doing, again, always left to right, look to see if it's regular. I think for when we're doing heart rate, that's probably important because that's all we're doing is heart rate. So make sure that each R wave is showing up where it's supposed to. Like you could expect where to see the next one because the number of little boxes is the same. So it's the same heart rate throughout the whole strip that you're looking at. And of course, you do it what we're all supposed to do. Look left to right. Is there a P wave? Is there a sexy P wave? Is the PR interval normal? Is the QRS normal? Followed by a T. And if all that is yes, let's do the heart rate. Now, here's the question. You got to answer me. Which beat from, how many beats are here? 1, 2, 3, 4, 5, 6, 7, 8 beats shown here. Which of the 8 is closest to a big line? 1 through 8, which would you pick?
Five.
Yeah, I agree. Definitely agree. So this is the 5th beat right here, if anybody's following. Excellent. So I would start here. I would start here. Remember, you don't count that one. Then you do, what's the first number?
300.
Next.
150.
Next.
100.
And next.
75.
Yeah, that's all we need. So we're between what 2 values? 75 and 100, right? And because it's regular, we could do the RR method anywhere we want. I mean, you could start here and count these boxes, but it's easier for me to do it here because it's 5, 10, 15, 16, 17, 18. So you'd have to divide 18 into 1500, and what do you get? So 1500 divided by 18. What do you wind up with?
About 84.
Yeah, it's pretty good. So is that within normal range? I'll say 84. That's cool. You can round it off. So 84 beats per minute, is that within the normal range?
Yeah.
Yeah. And you got to assume all this is at rest. So 84 beats per minute is acceptable. And is this P wave normal before every beat? Take a minute to look at it. Not even, just take a few seconds just to look to see that the P wave is there and it looks the same and it's normal. What do you think?
Yes.
It is. It is. I agree. And the PR interval is normal. So the PR interval is definitely between 0.12 and 0.2 seconds. So we can call this normal sinus rhythm because it's coming from the SA node, which is a normal sexy P wave. So it's normal sinus rhythm, which is NSR. And it has to be within range or you can't call it normal sinus rhythm. What would you call it if the heart rate on this EKG was 120 beats per minute? Remember, good sexy P wave, normal PR interval. What kind of tachycardia? You can't just say tachycardia. You have to say where the rhythm is starting. So if it's normal sinus rhythm, this would be sinus. That would be sinus tachycardia, right? Right?
Yeah.
Do you understand that? Because the P wave is there and it's normal, and the PR interval is normal, and the QRS complex is normal. What would you call it if same beats here, except the heart rate was 42 beats per minute at rest?
Would it just be sinus bradycardia?
That's exactly right. 100. That's a perfect answer. Very good. Thank you. So the key is you had to know that the rhythm was regular. Let me go back. The rhythm was regular. The P wave is good. The PR interval is good. The QRS is good. The heart rate was 84, which falls between 60 and 100 beats per minute. So you call that normal sinus rhythm. Now take a look at this one. Take a couple of seconds here and see what you come up with. And I'll ask you the questions. Take 10 seconds just to look at the way you're supposed to, left to right. Look for the P wave. Notice if the QRS is normal and is the rhythm regular, irregular, and is it repeating itself irregularly or not? Okay, first of all, is this rhythm regular? Is every beat coming at the same cadence?
No.
It's not. You're right. Like if you did the calipers here, they would be completely offline. Excellent. Thank you. And it's not even repeating itself. And I'll tell you it's not. It's not going to repeat itself. It's going to be irregularly irregular. So number one is irregular. And because it's not coming in at a consistent irregularity, it's called irregularly irregular. So we can't use the RR interval method here. So if you can't use the RR interval method, you can't use the 300, 150, 100 method. So what method do we use? There's only one left that we learned. The first one we learned.
6 second.
Right. So I'm telling you, this is a 6-second strip. So what is the approximate heart rate of this irregular rhythm? All you have to do is count the cycles.
70 beats per minute.
Yeah, it's 70 beats per minute. Because you see 7 cycles. 1, 2, 3, 4, 5, 6, 7. Now, based on heart rate, is that okay? Is that within range? That's all I'm asking. I'm not asking for where the rhythm is coming, but is that acceptable? Like if you did pulse and you're just counting the beats, is that acceptable? Is it within range? Yes or no?
Yeah.
Yeah, you're right. You're right. You're exactly right. And you're correct. Everything, basically, that's all you really need to know for today. But take it a step further. Like, look from left to right. Do you see a P wave before any of these QRSs? You don't. I know it's difficult right now because you haven't seen too much even of the normal, but there's no P wave there. It's just kind of fluttering and fibrillating. It's just like quivering almost.
Professor,
And
would this be an example of atrial flutter?
it's atrial fibrillation, actually, which is a little faster than flutter, because flutter could be regular. Atrial fibrillation is completely irregular. Very good. Very good. That's very good. So it is an atrial cadence. So what about the QRSs? Are they normal? They are. These are normal QRSs. They're completely normal. So do you know the conduction system at all? Like where in the heart is the cadence supposed to start? What's the fastest pacemaker of the heart? Which node? The SA node, the sinoatrial node. That's where you get the sinus rhythm from. So obviously this is not sinus rhythm that what we just looked at. It's atrial fibrillation because there's no P wave, discernible P wave anyway. So it can't be sinus rhythm. Now, what's the other big node in the atria? That's between the atrium and the ventricle, atrium and the ventricles.
With the AV.
AV.
That's right, the atrioventricular node. Now, the atrioventricular node is a slower node. It slows things down. And that's why there's a little delay between the P wave and the QRS, because it allows time for the ventricles to fill. So the AV node is going to slow down all those depolarizations that happened in the atria, because atrial fibrillation is like a massive atrial heart rate. Like the atria is contracting, going through systole, could be 400 beats per minute at times. But notice this EKG showed a 70 beats per minute ventricular heart rate. Because how did that happen? Take a guess. Like, how does that happen where the atria are just going crazy? The SA node is not working. So all the atrial cells have to have their own pacemaker potential because they're faster than the AV node. So the atrial cells start throwing out depolarizations and action potentials, and then the conduction goes towards the ventricles. So how do you get a normal ventricular depolarization and heart rate? Who saves the day? Like what node will save the day there to make sure you get good ventricular output, depolarization, systole, and ejection?
Is it the AV?
Yeah, the AV node slowed it down enough and it was working correctly that it actually showed you a decent heart rate, 70 beats per minute. Now, if you look at the EKG, this person has problems because they have atrial fibrillation, which is dangerous. But they're still getting good cardiac output, you understand? So the symptoms might not even be that severe. So it's controlled AFib because it's less than 100 beats per minute. Uncontrolled AFib is above 100 beats per minute. So you know you have tachycardia at the same time, but you just don't know where it's coming from because it's an atrial issue. Does that make sense?
Yeah.
Okay, let's go back. It's working a little better, the computer. Still not responding. Okay. So yeah, so that's the takeaway. Now I'm telling you this is a 6-second strip. I have to. I won't trick you on that. I mean, you can count the 30 boxes, but again, you just have to know that this is a 6-second strip, and it's irregularly irregular. You can't do the RR method or the 300, 150, 100. You have to use a 6-second strip. So keep that in mind. That's important. And this is just a drawn out. You should practice this. Like, again, we're not in the lab, so I can't give you a paper, but you'll get paper and then draw this and make sure you know how it should look. But don't forget the PR interval, which is really important. And now you can measure amplitude. Again, it's the height of the wave from the baseline, but this is important. This is what I think students forget. Like when you're measuring the amplitude of a QRS complex, you have to go from the negative wave to, like, here's the S wave to the top of the R. And then you count the little boxes. Remember, one little box is 0.1 millivolts, 5 little boxes is 0.5 millivolts. So 2 big boxes is 1 millivolt, which kind of makes it easier. Now this is an R wave. It's a QRS complex, but it doesn't show a Q and an S wave. That's fine. This is, you don't need to see the Q wave all the time, and you don't need to see the S wave all the time. And here's the amplitude of a T wave, because sometimes that's going to be important. Like sometimes the T waves get massive, and that could show a problem, like too much potassium, which you'll learn. You don't have to worry about it now, but an enlarged T wave is usually due to hyperkalemia, which is potassium, hyperkalemia, too much potassium in the blood. So when you hear emia at the end of something, it's a number of the blood. So that would be hyperkalemia. I'm just telling you that, just so why you'd measure the amplitude of a T wave. But for our lab, you're going to be measuring time more than anything, more than amplitudes. Pretty much that's all you'll do. So you really have to get used to those little 0.04 second boxes and the big boxes that are 0.2 seconds. Now the intervals are important, like you'll know the PR interval, which we talk about more than any of the intervals. QRS interval, which really should be less than 0.11 seconds. Because remember I told you before, you don't want it too wide. Like a wide QRS kind of looks like this. And there's the T. So this is the QRS. See how wide this is in length. So it's going to be pretty obvious. But for now, know what the normal looks like. Sometimes it's even smaller. Sometimes an R wave could be straight up and down, like really tight like that. Or like this, you know. And then there's the QT interval, sorry, which basically is representing your systole of your ventricles, ventricular systole. Okay.